Choosing a screened cable without a defined electromagnetic risk can add cost, termination complexity, and installation failure points while leaving the real interference path unresolved. Conversely, omitting screening where power circuits run beside vulnerable equipment can compromise system compatibility. The choice between NHXMH and NHXMH-ST must therefore begin with the circuit, route, and operating environment, not with the assumption that the more complex designation is automatically better. NHXMH commonly identifies a halogen-free, low-smoke power cable for fixed building installations. An ST notation can indicate a screened or shielded construction, but the exact meaning must be confirmed for the specific manufacturer and product family. Before comparing the two, verify the model designation, voltage rating, conductor and core arrangement, insulation, sheath, installation limits, applicable requirements, and declared test evidence. Halogen-free construction addresses only one part of building safety. It may reduce concerns associated with corrosive gases during combustion and support smoke management objectives, but it does not replace assessment of flame spread, circuit integrity, cable supports, fire stopping, evacuation strategy, or route design. Each required property needs to be stated and supported separately. The same principle applies to shielding. A screen may be relevant when power cables operate near instrumentation, controls, medical equipment, data-sensitive systems, or credible sources of electromagnetic disturbance. Its effectiveness depends on the source, the vulnerable circuit, route length, separation, earthing, bonding, continuity across joints, and termination method. Without a system-level compatibility plan, the presence of a screen is only a construction feature, not evidence of effective interference control. A disciplined specification follows 5 priorities. First, define the required fire and smoke properties and the evidence supporting them. Second, establish the circuit function, including whether operation must continue during an event. Third, identify any credible electromagnetic source and victim path. Fourth, confirm that the cable can be installed and terminated correctly along the proposed route. Finally, maintain an evidence chain linking the delivered reels to the approved schedule. Application conditions change the weight of each factor. In hospitals, fire-related material requirements and electromagnetic compatibility must remain distinct decisions. Sensitive equipment nearby does not automatically require screened power cable. Engineers must identify the disturbance source and actual equipment vulnerability, while installers need access, suitable termination space, and clear instructions for screen bonding and continuity. Airports and transport hubs combine high occupancy, dense services, long routes, control interfaces, and varied circuit functions. Circuits should be classified by duty and route so that fire performance and screening requirements can be assigned deliberately. In tunnels and rail facilities, restricted egress, smoke, maintenance access, containment, supports, and system reliability can be as important as the cable sheath itself. Where screened construction is considered near control, signaling, or monitoring systems, the interference concern, segregation, and bonding method should be documented. Mechanical and environmental route conditions may determine the cable family before screening is considered. Risers, conduits, ceilings, plant rooms, and underground sections can introduce bending, pulling, moisture, temperature, chemical, support, and maintenance constraints. Poor handling can damage a screen, while incorrect termination can undermine its intended function. Final approval should compare the exact model code, voltage rating, conductor size, core count, screen description, sheath, test evidence, and real identification against the cable schedule. The procurement file should include the model-specific datasheet, relevant reports, applicable certificate scope, shipment records, batch or real identification, and incoming inspection documentation. NHXMH-ST is not universally superior to NHXMH. It is appropriate when a defined electromagnetic or installation requirement justifies screening and the project can implement the necessary bonding and termination controls. The correct choice is the documented construction that matches the building risk, circuit duty, route conditions, and complete electrical design.